Number 1, graphing a triangle. A, 3 units to the front. 1, 2, 3. 2 units to the left. Make a parallel line to the y-axis and count 2 units. This point right here is going to be our A. 3, negative 2. 0, we do not go up or down. Point B, we're going to go no front or back. We're going to go to the right 3. 1, 2, 3. And then we're going to go from there up 2. 1, 2, and this is point B. Finally, for point C, we do not go to the front. We go to the right 5. That's 4. That's 5. And then we're going to go down 3. 1, 2, 3. This is the point C. If you do connect those 3 points, you're going to form a triangle. And that will be the triangle we're going to work more with on part B and C. To determine if the triangle is acute, obtuse, or right triangle, I need you to find the distance from A to B using the distance formula. I need you to find the distance from A to C using the distance formula, and the distance from B to C using distance formula. I did that ahead of time, and let me tell you what I found out those distances to be. Distance from A to B, I found it to be square root of 38. The distance from A to C is square root of 67. And the distance from B to C is square root of 29. Now what we want to do, we want to select the largest of these 3 sides. Square root of 38, 67, and 29. It seems to me this is the largest. I'm going to call this one C. I want to compare C squared to A squared plus B squared. Based on the formula, if these are equal, it will be right. If C squared is bigger, it will be obtuse. If C squared is smaller, it will be acute. In this case, when you do square root of 67 squared, compare it to square root of 38 plus the square root of 29, each one squared, you will find that those quantities are the same. 67 does equal 38 plus 29. Since it is an equal, this triangle is a right triangle. And that would be part B. We got the triangle to be a right triangle. Part C is the area of the triangle. I want you to pick on 2 adjacent vectors. I'm going to pick on a vector AB, put it in component form, vector AC, and put it in component form. If B is the terminal and E is the initial, we're going to do terminal minus initial and find out vector AB is going to be negative 3, 5, 2. The same thing for AC. C is terminal, A is initial. The component form of this vector will be negative 3, 7, negative 3. In order to find the area of the triangle is 1/2 the magnitude of the cross product of these 2 adjacent vectors, AB cross product AC. So first what we're going to do, we're going to find the magnitude, the cross product, then we'll find the magnitude and then multiply it by 1/2. So here is the cross product. The cross product is going to be, the first row is I, J, K. The second row is vector AB, negative 3, 5, and 2. The last row is going to be negative 3, 7, and negative 3. The expansion here, remember to change the sign on the J. I is going to be multiplied by the component of 5, 7, 2, negative 3. Negative J is going to be multiplied by negative 3, 2, and negative 3. And then vector K is going to be multiplied by, that's a plus K, and K is going to be multiplied by negative 3, 5, and 7. Okay, here we will have to cross multiply this way, which is give you negative 15. Multiply that way, you will get 14, and you'll always subtract. And so that will give you negative 29i. Negative J, we're going to multiply this way, you will get a 9. Multiply this way, we'll get negative 6. Minus negative 6 will give you positive 15. So this will give you negative 15J. Last, we're going to multiply those two. We're going to get negative 21. And then when we multiply this, we'll get negative 15 minus negative 15 is going to be plus 15. Plus 15, it's going to be over here, 15. And so when I multiply it out, we'll give you negative 21 plus 15 will give you negative 6K. Okay, so now what we did, we found the cross product. Now to finish up with the area is going to be 1/2 the magnitude of 29 squared plus 15 squared plus 6 squared. I want you to multiply it out, I want you to add them up, but I do not want you to reduce the radical. So leave them in radical form. Okay, the area is square root of 1102 divided by 2. This does not reduce. You can leave it in reduced radical form. You don't need to give me a decimal. This is fine. Just leave it alone. Next, we're going to do part D. Part D, we're going to find the equation of the plane containing those 3 points. I'm going to draw the visual for you. This visual tells you there's 3 points in the plane, and these points we're going to call them A, B, C. And as you can see from the previous part, I already have vector AB, I already have vector AC. In order to write an equation of that plane, I needed a point in the plane. I'm going to call it x1, y1, z1, and I'm going to pick the point A. And in this case, the point A is 3, -2, 0. I also need a vector. We're going to call that vector ABC, and I want that vector to be perpendicular to the plane. We already did in part C, we did find that vector that is orthogonal to BAB and AC, which we did the cross product, and that vector happened to be -29, -15, and -6. All what we have to do at this point is go ahead and write the equation of the plane. To write the equation of a plane is going to be this way. A, which is -29, x minus 3 minus 15, y plus 2, and then -6, z minus 0. We want to simplify this to put it in general form. It will be -29x minus 15y minus 6z. If you add this product to this product to this product, I got 57. Now we decided already general form, the leading coefficient should be positive. So I'm going to multiply everything by -1. And so the equation of that plane will be 29x, 15y plus 6z minus 57 equal to 0. Number 1 is done.